All right, guys. We're gonna do graphing today. Uh, the idea. We're gonna first of all spend a couple minutes talking about where sine cosine graphs come from, and then we're gonna talk about stretching them vertically, which would be an amplitude change. We're gonna talk about stretching them horizontally, which would be a period change. And we're going to talk about shifting them vertically up and down. Okay. We'll save for tomorrow the fun stuff where you got to shift them to the left and right, which means, shift it to the right pi over 6, and then the period is 3 pi over 4 or some disgusting thing. We'll do that tomorrow. All right. So the first thing I want you to really understand, I'm hoping, is that sine comes from the y values. What is the y value at that ordered pair right there? The y value is 0, so we start at 0, okay? If we go around to pi over 6, what happened to the y value? It's this little piece, right? So it's like this. And then if I go up a little bit more to pi over 4, the y value gets a little taller, yes? And if I go up a little bit more to pi over 6, the y value gets a little bit taller. And then if I go all the way around to here, what's the y value up to? Okay, so at pi over 2, the y value is all the way up to 1, yes? Okay. What happens to the y values as I continue around this way? They go back down, but are they positive or negative? They're still positive, right? But they're getting shorter again? Do you understand why I'm drawing my little red lines up and down? Because they're y values, yes? Okay. Okay, they get shorter. Now what happens to the y values as I go down this way? As I rotate around to here, the y begins to get longer again, but what? But it's negative. All right, eventually, what does the y value go down as far as? -1. And where is that at in radians? Do you know what that is in radians? 3 pi over 2, right? What? This is pi, right? Where we hit 0 again here for the y value. Right? And then as we continue this way, the y's are still negative, but they're getting what? Shorter again? Everybody good? Yeah, mine is not good, but okay, gets back to 0. So we're supposed to get something that looks like this. Everybody should have seen this at some point. I did a lousy job, but does this look familiar to everybody? Okay. So this is the sine graph. It goes through the origin. Its maximum is 1. Its minimum is -1. Its period is 2 pi. Now, I drew one period, right? It would continue if we continued to rotate around the circle. Does everybody get that? Okay. So my question is, domain and range? Domain is -infinity to infinity. As long as we aren't restricting it left to right, it continues forever. Range, though? -1 to 1 with square brackets, right? Maxes out at at 1 and minimum is -1. All right. Is this an even or odd function? Does anybody even remember what that means? It has to do with symmetry. Even is y-axis symmetry, which would mean something like this, like a parabola. Odd is origin symmetry. Does anybody remember what that looks like? Looks like this, right? Origin symmetry means it's the same upside down. So it's doing something like this one is, or a cubic, or tangent graph. So this is an odd function because it looks the same if I take and flip it upside down around the origin here. Okay? We good? I think one of these has a, so let's see. This is a sine function right here. Oh, what are we supposed to say? Oh, we're going to talk tomorrow about music and frequency. So the amplitude is going to be multiplied in front. Sine or cosine? Okay, because it started at the origin. To make it a larger amplitude, what happens? Okay, it goes further from the x-axis, right? Very flat. Notice it didn't say B is the period, it said B changes the period. We'll talk about frequency tomorrow. Okay, so for that piston, the period is how long it takes to make one complete cycle. Today's shift tomorrow. All right, back to this. One of these has just an animated. Okay, so if we go around, which one's the sine, guys? Sine should be 0 right here, yes? As I rotate around, you see it's making the green line up and down. Can you see the green? So it's tracing out the green over here on the right. Okay, it has it in degrees. I can change it to radians. Okay, are we good? Do you see where the little segments we drew a minute ago are working over there? All right. I don't know what the other one is that I have on there. Oh, it just, this one is it showing the height, the red, as it draws the sine graph. Okay, this one is showing the one we're going to do right now, which is the x. All right, so let's go back and do the cosine. All right, so the cosine is the x value. The x value is what right here? Okay. So I graph it still over here though as a height because I'm graphing the amount of rotation, okay, here, versus the value of the cosine is what we're graphing. So even though it's an x value here, it's the value of the cosine here. All right, then what happens when I go up to here? What happens to that x value? How far over I went shrinks, right? If I go up a little further, the amount I went over shrinks even further until what? Yeah, up here at the top, I go over none. So this is 0, 1, which means it's 0. And that's at 90 or pi over 2. Okay, it was getting shorter. And what happens to x values as I move into the second quadrant? I'm going left, yes? What does left mean? Okay, it's negative. I go left further and further and further until I go all the way to -1. So I'm going left, 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 all the way to -1. Then down in this quadrant, the x value at these points is what? Still negative, but getting shorter? Until, what's this spot down here where it's 0 again? 3 pi over 2? And now the x values do what as we go to the right again? They become positive and they get longer until we're back to 1. All right. So I drew one period. If I were to continue this pattern, both directions, the domain and range are going to be what? -infinity to infinity, and the range is still -1 to 1. I don't know why I have two negatives there, sorry. These are really just shifts of each other, right guys? You know this from doing your unit circle quiz, that those x and y values repeat, and the x's and y's had the same numbers in them, they just moved around. So we're graphing this time what kind of symmetry does it have? Okay, it has y-axis symmetry. Here it's symmetric on either side of the y-axis, so it is an even function. All right, amplitude is what? Amplitude is the height of the graph. How far above and below? Actually, the definition of amplitude is max minus min divided by 2. So if we say I went up 1 and down to -1 divided by 2, it comes out what? The amplitude is just 1. Everybody okay? That's how far above and below the midline it goes. The midline would be at the x-axis or y equals 0. And the period? Yeah, it took us 2 pi to complete one cycle. All right, and we didn't write that for the sine graph, but it's the same, yes? Everything is the same? The period and the amplitude and the midline are all the same. All right, so this is out of your book. what did we talk about? We talked about the domain and range. We didn't talk about the y-intercept. The sine crosses at 0, 0. The cosine has a y-intercept of 0, 1. X-intercepts for a sine graph that's not shifted at all, it crosses at pi, 2 pi, 3 pi for the x. The x-intercepts of a cosine graph without a period change would be pi over 2. It says every half a pi where you get integers. So you get 1 pi over 2. That's weird to me. It has to be odd integers, doesn't it? All right, I'm never going to ask you x-intercepts, y-intercepts. This symmetry we talked about, that's important. I'm actually not going to ask you where the maxes and mins occur because it's going to be dependent on the period again and the so forth in any horizontal shift. End behavior does not exist. It doesn't have a limit. Does everybody understand that? Because it just keeps going above and below. Okay? So it doesn't approach +1 or -1. It's what the term we're going to use, or you will use in calculus, is that it oscillates between those. All right. If you took trig last semester, I'm not sure how Miss Osar teaches it. I think she does it like this. In Algebra 2, Honors Algebra 2, I know you do it like this, and this is the way I'm going to do it, okay? If you learn that this affects period, the only difference is the phase shift on this one. When you have not factored the b out, the phase shift is negative c over b. If you factor the b out, then the phase shift is just negative c. Okay. So guys, if I wrote this, and then I took the 4 out, okay, this describes the shift as left 2, yes? Whatever we were doing last semester, this would take the function and move it left 2. Everybody good? This, if I asked you what the phase shift was, most of you would say it wouldn't have one. You'd say I'd move it up 8, okay? But if this is the whole value here, I always just factor it out, okay, to describe the phase shift. We'll practice that some more tomorrow. All right, the amplitude of any sinusoidal function. I need to get you really used to this word. Guys, sinusoidal does not mean sine. It means sine or cosine, okay? When you see sinusoidal function, it just means any function that's repeating. Because when we get to modeling, if I say write a sinusoidal function, if I don't tell you, you can use either sine or cosine, whichever one looks like it fits the graph better, okay? So I need to get you used to that word being either one. So the amplitude is simply, it says half the distance between the max and the min. That's what I wrote down earlier, right? All right. So it's how far above and below the midline it goes. The period is the distance between any two sets of repeating points. So it's the distance between the max and the next max is a period. Does that make sense? The period for sine and cosine is going to be 2 pi over whatever the absolute value of b is. That b is going to affect the period. On your notes, it says that here. Okay. The amplitude is always positive. If we have a negative value for a stretch, that's the negative is a reflection. Same as we had this, right? This was a vertical stretch on our parabola, but it was reflected over the x-axis. It's the same when we do sine, -2 sine. The amplitude is positive value. Frequency we're going to talk about tomorrow. The vertical shift is the average of the max and the min. Okay, because it's the midline. So you want the middle. All right. When you go to graph a sinusoidal function, if you find the period of the function and then you add a fourth of the period to the left end, then you'll get the key values for the x. We're going to call those quarter points. And that is what I'm going to require you to graph and to give ordered pairs for. So if we eventually do shifts tomorrow, when you start here, you're going to take, well, I need to end here. And so you're going to divide that into fourths because I'm going to want to know the ordered pairs at all those places. Actually, not here on the graph. Okay, so this is how you find quarter points, and we'll talk more about that. All right, so let's talk about this graph. It does not have a vertical shift or phase shift. It is a cosine graph. So the shape is going to start at the maximum and go down, right? Okay. What else can you tell me about this? Okay. The amplitude is the A value out here, and that value is 2. So the maxes and mins will go between what? 2 and -2. What's the B value here? It is 1/4. Is everybody okay with that? That this is really 1/4 theta? Okay, but do you remember what it said for period? It's for a sine and cosine graph, the period is 2 pi divided by b. That's not pretty, right? When you divide by a fraction, you do what? So this is 2 pi times 4/1, which is 8 pi. What does that mean? No.
8 pi.
Yes, it means that this has been stretched horizontally so that it will not finish a rotation until 8 pi. Okay? Now, it's going to start where? Because it's a max, it's going to start at the maximum, yes? Or because it's a cosine, sorry. Because it's a max. Because it's a cosine, it's going to start at the maximum, which you told me was 2. All right? I like to just draw a little dotted line to remind myself that I'm never going to go above that. The minimum is going to be at -2. And it's cosine, so it's starting at the maximum. Now, I like when I don't have graph paper, because then I can just draw it how I want and go back and label those points. And if you prefer to do it that, on the quiz, I did not give you graph paper, okay? On worksheet 11, that's homework, there's graph paper already there. If you want to do it on a blank piece of paper, that's fine. If you don't like trying to fit your sketch to the graph paper, if you'd rather just sketch it. So since there's nothing here, I'm just going to draw a cosine graph, which is really a quarter circle, a quarter circle, a quarter circle, and a quarter circle going this way. Okay. Didn't draw mine very well, but you kind of get the idea. It should be doing this, okay? What the directions are going to say for the quiz are to label at least 5 ordered pairs in one period. That means you can't just decide to label, you can't draw 5 periods and label 0, 2, 8 pi, 2, keep going forever, okay? You got to label these points in between, these quarter points. Okay, where did we say this finished one period at? 8 pi. So this ordered pair up here is 8 pi over and up 2. Are we good? This one was 0, 2. All right. Now it said a minute ago, if you divide by 4, you'll get the quarter points. So what is 8 pi divided by 4? 2 pi. So those are the quarter points. This is 1 2 pi. The next quarter point, or the minimum, is 2 2 pi, which is 4 pi. And this one is 3 2 pi's, which would be 6 pi. All right. So this is 2 pi 0. What's this ordered pair down here? 4 pi negative 2, 6 pi 0, and 8 pi 2. Is it coming back to you? All right, let's try number 2. What can you tell me? Sam, tell me one thing. Both of you. You pick first. Okay. Other Sam, what do you want to tell me? The period is 2 pi divided by b, which is 2. Yep, because b is 2 right here. So the period is pi. Good job. What about the general shape? Anybody? Good, Michael. It starts at the origin and it's going to go up and down because it's sine. All right. So if I were to just draw one period starting at the origin, it would go up. Oh, I didn't do a very symmetric job. I'm not good at this. The important thing to me, guys, is your graph should not look like a V. Okay, it should be curving. If you can try to make these even, that would be good. Mine aren't very good. So, like I said, I like to draw it on blank paper because then I can put my numbers anywhere I want, right? Whatever fits what I drew. So what are my max and my min? 3 and negative 3 because of the amplitude. What else do I want to label? One of the Sam told me the period was pi. So where does that pi value go? At the end before it turned dotted on my picture, right? This is pi. And because it's a sine graph, it's over pi and up 0. Now, quarter points mean you're going to divide by 4. So if you take that period and divide it by 4, all of the points along the way at the maxes and the mins are going to be pi over 4. So this is going to be 1 pi over 4, 2 pi over 4, which reduces to what? Pi over 2, 3 pi over 4, and then 4 pi over 4 is 1. That seem okay with everybody? All right, so ordered pair up here at the top. Pi over 4, 3. This one was 0, 0. This one is pi over 2, 0. And then the minimum down here. Okay. So you should have 5 ordered pairs if you've drawn one period. That's going to be the requirement for the quiz. Any questions so far? How many of you in this class just came out of trig? Only one person just had trig last semester? Okay. So it's been a while for the rest of you, yes? Is it coming back to you a little bit? Yes. All right. We have to be careful on this one because, guys, the amplitude is not negative 1/2. Do you remember what it said? It had to be positive, right? What is that negative doing? Yeah, it's reflecting it over the x, which means when I go to draw my little shape, I usually give myself a sketch to remind myself. It's going to, instead of starting at the max, cosine usually starts at max, right? It's going to start at the min. It's going to do something like this. All right. And what else is going on? B is 3, so the period is 2 pi divided by 3. Lovely. Yes? Okay, we can do this. No vertical shift yet. So because it was reflected, it's going to start down here. We have a quarter, circle, a quarter, circle. Oh, that was really bad. And a quarter. Okay. Where it finishes here should be 2 pi over 3. Okay, 2 pi over 3. Quarter means divide by 4, which means 2 pi over 3 gets multiplied by 1/4, which is 2 pi over 12 or pi over 6. So this point is going to be 1 pi over 6. The maximum is going to be 2/6, which is what, guys? Pi over 3. Then the next x-intercept is 3 pi over 6, which is pi over 2, right? Reduces. And then 4 pi over 6 should get us back to 2/3. All right. I didn't put the amplitude on here. What should our maxes and mins be at? 1/2, which means it's really very short, right? I just didn't do a good job at that. So this is 0.5 and negative 0.5, okay? If I went back and drew that one on this graph, it would have been very much shorter, and it would have had a different, okay? You see what I'm talking about? Just so you could, in comparison, I didn't do a good job because I didn't scale these well at all, but this is 0.5. All right, so give me the order pairs. This one right here, anybody? 0, negative 0.5, or negative 1/2. This one? Pi over 6, 0. This guy up here? Pi over 3, 1/2, or 0.5. And this guy? Pi over 2, 0. And this guy? 2 pi over 3, negative 1/2, or negative 0.5. Okay. And is this have what kind of symmetry? Yeah, it's even function. It has y-axis symmetry, right? I just didn't keep going this direction. Any questions? All right, are we going to get to one with an amplitude or a vertical shift? Okay. This is a vertical shift. Yep. If you type this in your calculator, you would need to close the parentheses around the theta, okay? The book just doesn't ever put those in unless there's unless they absolutely have to put them in. Yes, you put it around the theta, not the 3, if you were typing it in your calculator, okay? Now, that means that this is, here, let me write y equals a sine b. If we had a c, it would be in here. Let me rewrite that. So this is actually a d, which affects the vertical shift, okay? It's not the number that changes the phase shift. So the amplitude is going to be what? 2. It's a plain old sine, so the shape is going to start at the origin and go up and down like this. The other thing that, well, what's the period? Yeah, there is no b value. B is just 1, so the period is just 2 pi. And the d value, which is the phase, is the vertical shift, sorry, is up 3. Okay, now, I don't know what your teachers did last year, and I don't know what Miss Osar does. I am not a big fan of just renaming this, but I will let you do that if that's what you're used to, okay? I don't care. I usually shift the whole thing. So if I'm going to go up 3, I usually take and draw a new midline at 3. This is y equals 3, and that's the midline. And then the amplitude is 2. So 2 units above that is 5. And that's where all the maxes are going to be. And the mins are going to be 2 below that, which is going to be at 1. Now, I know what a lot of the teachers do, and I'm okay with it, is they rename this line y equals 3. Yes? And then they say go 2 above and 2 below. So this is going to be 5 and this is going to be 1. And I'm okay with that as long as you write your ordered pairs accordingly. Okay? All right. It's a sine, so it starts at the midline and it goes up. Whoa. And back to the midline and down and back to the midline. Okay. And the period finished where? 2 pi. Guys, notice 2 pi is really here. Okay, then we're going to write an ordered pair here. If we take 2 pi and we do quarter points, we divide it by 4, we get pi over 2's. So there's going to be a pi over 2 that's important, a 2 pi over 2, which is pi, and a 3 pi over 2 that's important. All right, so help me write the ordered pairs the way I've drawn it here. 0, 3, pi over 2, 5, pi 3, 3 pi over 2, 1, and 2 pi 3. Okay? If you did it on this graph, okay, it's the same. The problem is I always get students who want to write pi 0 here when they go back and write the ordered pairs. This is not pi 0 because this line you told me is 3, right? All right. And then you got to go back and put in the quarter points. Everybody okay with one way or the other? All right. I'm going to go back and do one more of those, I think. But your assignment tonight, guys, everybody listen, this is on worksheet 11. You don't have to do all of them. Okay, and these are not all graphing questions. The last couple are like, tell me what the amplitude, period, etc. are. Okay, it's on the gold sheet. The assignment is on the gold sheet. All right. Do you want me to do 5 or 6? Or do you want to just talk about both of them? Or what do you want to do? Okay. This one has an amplitude of 1. But the b value is 1/2 here. So the period is going to be 2 pi divided by 1/2, which will be 2 pi times 2 over 1, or 4 pi. And the minus 4 is a vertical shift down 4. So if I go over here real fast and I say this is my midline at negative 4, 1 unit above that at negative 3, and 1 unit below that at negative 5 are where my maxes and mins are going to be. It's a cosine graph, so it starts at a maximum and it finishes at a period of 4 pi. So if I divide that by 4, I get pi. So this is pi negative 4, 2 pi negative 5, 3 pi negative 4, and 4 pi negative 3. Okay, I'm going to really super fast talk about this one because what's going on this one? It's shifted up to 1. Yes, the amplitude is 3. So if this is 1, it goes up to 4, and 3 below 1, guys, would be negative 2. And it's a sign which starts at the midline, but it's negative, so it goes down. The period is still 2 pi, so this would be 2 pi. Pi. All right? Yeah, I'm recording the